Welcome back everyone, Patrick here, and in this next video what we have to do is list coordinates that are either 4 units from this coordinate, 4 and 3, or root 5 units from this coordinate, -3, -7. So a fairly popular question that can come up, and there's many ways to do this. So starting with the first one, let me actually show you the easiest way to do it. So let's first draw the point 4 and 3. So that's going to be like over here. Now, the easiest way to do this is to find points that are either at a horizontal or a vertical distance. So 4 units from 4 and 3. Well, what if we go 4 units to the left? Well, notice we're at an x value of 4. So 4 minus 4 would give us an x value of 0, and keeping that y value the same, the y value would still be 3. So a potential point would be 0 and 3. Or you can go the other way. You can add 4 to the x values. You can go to the right, and so that would give you an x value of 8. Y value would still stay the same. So that's doing a horizontal distance, going to the left or to the right. You could also go vertically, so you can go up 4 units. So then the x values would stay the same, but then the y value would change. What's 3 plus 4? That would give us 7. 4 and 7, right? A y value of 7 going up by 4 units. Or you can go down by 4 units. So if we're at a y value of 3 and we go down 4 units, well, now we would be at a y value of -1. So then the point would be 4 and -1 right there. Right? So those are usually the easiest 4 coordinates to get going horizontally or vertically. Now, a tougher way to do this is to get points where the distance is going to be a slant distance. So let's say that this question said list coordinates that are 4 units from 4 and 3 with, let's say they specify a certain x value. So let's say with an x value of, I don't know, let's say 2. Right? So now what's going to happen, let me erase these other points. Now this question becomes a lot tougher. Because now the x value of the point has to be 2. And so notice that the point is either going to be, let me erase this 7 as well. The point is either going to be, if you think about it, somewhere up here, or it's going to be somewhere down here, either above or below the x-axis. If it's at 4 and 3 and then at 2, let's just assume for now it's going to be above the x-axis. But if we end up getting an answer below, then we could plot that then. Right? So notice it's going to be a slant distance then. And both of these points are going to contain an x value of 2. The question is, how would we get the corresponding y value? Well, what we can do is we could use the length formula. So we know that the length is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's between points x1, y1, x2, y2. So what we can do is we can label these. So let's label the 2 and y that we're finding. Let's label that x1, y1. And then let's label the 4 and 3, the point we're given, x2, y2. So plugging everything in, well, we know the length has to be 4, so we would plug that in on the left side. And then we'd have the square root of x2, 4, minus x1, which is 2, squared, plus y2, which is 3, minus y1, which is y, that's what we're solving for, and then that's going to be squared right there. And now notice we have an equation with one variable to solve for. There's going to be a lot of algebra to solve for it, but nevertheless, we do have a variable we can solve. And then when we actually solve this, what's going to happen is we're actually going to get two different y values representing these two different points. So from here, what you want to do is you first want to get rid of this big square root on the right side. So what you would do is you would actually square both the left side and the right side. So here, let me continue this over here. You'd end up with 16 equals whatever's under that square root, like that, right? Because square root of something, when you square it, the exponent and then the square root cancel out, so you're left with whatever's below the square root, and then 4 to the power 2. What you did to one side, you got to do to the other, so then 4 to the power 2 gives us 16. And then from here, you just want to kind of work this algebraically. So 4 minus 2, notice that would give us 2. That's going to be squared. And then this, let's keep as is. And then over here, what we would end up with is 16 equals 4 plus 3 minus y squared. Bring the 4 over, so you'd have 12 equals 3 minus y squared, like that. And then what you want to do is you want to get rid of this exponent here. So this exponent 2, what you would do is you would actually square root both sides. So notice here we wanted to get rid of the square root, so we squared both sides. Well, now we want to get rid of the exponent 2, so we would square root both sides. And so what we would end up with then is root 12 equals 3 minus y, like that. Now, where the two different solutions come from is at this step, because when you take the square root of something, well, it could be plus or minus, right? So for example, the square root of 9 is plus or minus 3. Well, the square root of 12 is also going to be plus and minus. It's going to be 3 point something. I'm just going to keep it as an exact value for now. But the answer here is going to be a plus or minus. And so now, isolating for this y, notice we have a negative y here. So I'm going to take the negative y, I'm going to bring it over to the left side to make it positive, to isolate for it. And then this plus or minus root 12 I'm going to bring over. And then it still ends up just being 3 plus or minus root 12, because then this positive would turn into a negative, but then this negative would turn into a positive. So you still end up with plus or minus. And so the two y values that you would have, because notice it's a plus or minus here, so there's two solutions. The two y values would either be 3 plus root 12 or 3 minus root 12, like that. Now, if you wanted to get the actual decimal value, so the square root of 12, if you round that to 2 decimal places, that would be approximately 3.46. So then you'd have 3 minus 3.46. And then from here, you just add these, you'd get 6.46. And then here you'd subtract these 3 minus 3.46, so you'd get negative 0.46, like that. So notice that this y value, it's actually negative. So this point should actually be below the x-axis, right? It's going to have a negative y value. So this point would be here. Okay, this is not to scale, but basically what's happening is we got the y value of both of these points. So this point, two ways to represent it. You may see two different solutions in a textbook to this. So you may either see 2 and this value, 3 minus root 12, if they leave it as an exact value, or you might just see 2 and negative 0.46 if they show the decimal. So whichever one they show, that's how you get it. And then this upper point, we would have 2 and then 3 plus root 12. or it could be shown as 2 and 6.46, positive 6.46, like that. Okay, so that's how you can get points when they specify a certain x or y value. Okay, that's the way that you would go about it. So if they don't specify it, then it's easy because you can just get the horizontal or the vertical points, the horizontal distance or vertical distance from the point that you're given. But if they do specify a certain x or y value, then it's going to take a little bit more algebraic work, but this is the process in which you go about it. Now, what if they specify a certain y value? So let's say they specify, let's erase all of this. Let's say that they say instead of an x value of 2, let's say they specify a y value of, let's say a y value of 2. Okay, so let's draw this again. So we'll have 4 and 3, which is like here, but then it has to, the points we're looking for have to have a y value of 2. Okay, so it's either going to be over here. Now this point might be to the left of the y-axis, and if it is in our final answer, we'll just adjust the drawing. But for now, I'm just going to draw the point here. And then the other point is for sure going to be somewhere over here, like that. So notice in this case, we're going to be solving for the x values because we're given the y value of 2. So we got x and 2. And then over here, we got x and 2. You can maybe label this like x1 and 2, x2 and 2. I'm just going to leave it as x for both of them because that x value that we're going to solve for, there's actually going to be 2 solutions for it. So same thing, you would use the length formula. It's just this x and 2. Let's label this x1, y1. This will be x2, y2, like that. So using that length formula, let's rewrite it. Well, it's going to be the same process. So we would end up with the length has to be 4, right? We're given that length. And then we're going to have the square root of x2, which is 4, minus x1, which is actually what we're solving for. That's the x value that we're going to solve for, squared, plus y2, which is 3, minus y1, 2. And then that's going to be squared, like that. And so from here, same process. First we got to square both sides. So we'd have 16 equals whatever's under the square root. And then this is going to be 1 squared. 3 minus 2 is 1. That's going to be to the power 2. So that's actually just going to end up being 1. Bring the 1 over. 16 minus 1 is 15. Sorry, this should be squared. Like that. And then to get rid of this 2 here, we would square root both sides. So we'd end up with root 15 equals 4 minus x. And then what we want to do, bring the x over to change it to a positive. This is going to be plus or minus. Bring that over. It still stays as plus or minus, so we're going to have plus or minus 4 plus or minus root 15. Okay, so the two x values that we get is either 4 plus root 15, which is going to be this point, or we're going to end up with 4 minus root 15, which is going to be the smaller x value, which is going to be that point on the left. And if you want to get the corresponding decimals, the square root of 15 is going to be 3.87 approximately if we round it to 2 decimal places. And so we would end up with 7.87, or 4 minus 3.87 is 0.13, like that. So those are the two x values. So this point, it's either going to be two different ways to represent it. We could represent it as 4 plus root 15 and a y value of 2, or we could represent it in decimals 7.87 and 2, like that. And then this point over here, notice the x value is positive, so it's actually to the right of the y-axis, right? It's a positive x value, so the drawing was correct over here. We don't have to move this point to the left of the y-axis, but if we got a negative over here, then this point would be, we'd have to adjust the drawing. It'd be over here somewhere. So this point, it could either be 4 minus root 15 and 2, or 0.13 and 2, like that. So those are the two different points that have a y value of 2 that are 4 units from this point. Okay, same exact process, it's just now the variable that we were solving for was here instead of being here as it was last time. Okay, so that is the process. Now, what about B? Exact same thing. It's just in this case, we're given a length that is a square root, which is possible because a lot of times the lengths that we get, as we seen in previous questions, can be square roots, where it's not just going to be an integer, it's going to be an irrational number. But same process applies. So what we can do is, let's first draw the point. So we got -3, and then let's say -7 is like down here. So here's the point. This is -3, -7. So again, the easiest way to do it, if they don't specify any x or y values, is to take this point and either go √5 units to the left, to the right, up, or down. So if we go to the left, notice that the y value is still going to be -7, but we're going to be subtracting from this x value. -3, we're going to be subtracting √5 units. So this new x value would be -3 minus √5, like that. And √5 in decimals, it's approximately 2.24. So if you wanted to show this in decimals, it'd be -3 minus 2.24, which would give you -5.24 and -7. Okay, so that is one potential. We can also go to the right. You know what, I'm actually going to move this just to make it a little bit more to scale here. What we would do is we can pick another point over here, right? We would go √5 units to the right. So in this case, the y value would still be -7, but now it's -3 plus √5, because we're adding √5 units to the x value of -3. So this point here would have that new x value. Instead of subtracting √5, we're now adding √5. Okay, and if you wanted this in decimals, -3 plus 2.24, that would give you -0.76 rather. Like that. So both of these points, this point and then this point, are √5 units away from this point, -3 and -7. Now, what if we went up or down? Well, then we would be adjusting the y values. okay, the x value would stay the same. So if we went up root 5 units, let's say this is going to be like over here, well, this point, the y value, or no, the x value rather, is going to stay the same, but we're going to be adjusting this y value of -7. So if we're going up, we're going to add to the y value. It's going to be -7 plus, let me actually give myself some room here, -3, then it's going to be -7 plus root 5, like that. Let me actually erase these other points just to clear up the whiteboard here. Right, this point here, we're adjusting the y value, the x value is staying the same. And then if you wanted the decimal for that, it'd be -3, then -7 plus 2.24 would give us what? -4.76, like that. Right, so notice that this y value is greater than -7, right? It's going to be up here somewhere. So that's as an exact value, that's as a decimal. Now, what if we got a y value down here? Well, now, this point here, notice the x value is going to stay the same. It's still going to be -3, but we're going to be subtracting root 5. So now we're going to have -7 minus root 5, or -3 and -9.24. Right, so that's how you would find points either to the left, to the right, up, or down from that point that you're working with, -3, -7, and again, that's the easiest way to do it. But now let's add a little bit more parameters here, more conditions. So let's say root 5 units from -3, -7 with an x value, let's say of -1. What would happen then? Well, now what's going to happen is we have to have an x value of -1. And so what's going to happen is root 5 units is either going to be over here, a point over here, or a point down here. Right? So both of those lengths are going to be root 5 units. So this is -3, -7. Here we've specified the x value, and we're going to be solving for the y value. So exact same process is going to happen in this case. We're still gonna, let me start it here. We're still gonna use that length formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's let this be x1, y1. It doesn't matter the order. You could let this be x1, y1, this be x2, y2. You're still gonna end up with the same answer in the end. So in this case, the y2 is what we're going to solve. Now the length over here is root 5. So before it was a decimal, but now, you know what, actually, I'll just write root 5 like that. Or before it was not a decimal, but an integer, 4 units. Well, now it's going to be a decimal here, or an irrational number is going to be root 5. And then this right side is going to stay the same. So we'll have x2, which is -1, minus x1. So be careful here with the brackets, right? The -3 goes in brackets. That's going to be squared. Plus y2, which is y. That's what we're solving for. Minus y1, which is -7, like that. And then that's going to be squared over here. Now, what's nice if you get something like this is you actually don't have to square both sides. You can, but notice that we have the square root of something equals the square root of something. So we have roots on both sides, so we could just drop both roots. So basically, all of this here has to equal 5. If you do want to show your work, you would just square this side, square this side. Square root of 5 squared is just 5. Versus before, the 4, we had to square it, and we got a new number here, 16. Well, now we're just going to have 5 on the left side. And then that's going to equal, let me write out these brackets still. Like that. Just keep everything in brackets. Okay, if you're working with negatives like this, I actually recommend doing square brackets and then putting the x2, x1, y2, y1 in brackets of their own, just so you're not missing any steps here. Okay, so now, just continuing this here, we'll have 5 equals, now -1 minus -3 is like -1 plus 3. The two negatives turn into a positive. -1 plus 3 gives us 2. So inside this square bracket is going to be 2. That's going to be squared. Plus, over here, this can't simplify, the y and the -7, but notice these negatives turn into a positive, so we'd end up with y plus 7 over here. And then that's going to be squared. So what happens here? 5 equals 4 plus y plus 7 squared. Bring the 4 over, we'd end up with 1 equals y plus 7 squared, like that. Now what do? We square root both sides. What's nice about this is square root of 1, that's actually a smooth number. That's equal to plus or minus 1, and then we got y plus 7, like that. So we don't have to worry about square roots in this case. So notice that the two y values, the y is already positive here, so I'm going to bring the 7 over. So basically we'd end up with plus or minus 1 minus 7 is equal to y. Before it was negative, we brought it over, and then we brought this over. In this case, it's already positive here, so I'm going to just bring the 7 over. It becomes a -7. And so notice that the two y values is either plus 1 minus 7 or -1 minus 7, like that. So we'd end up over here, 1 minus 7 is -6. Over here, we'd end up with -1 minus 7, which gives us -8, like that. And so, erasing all this here, the two different points, -6 is above this point, above this y value of -7. So this point, it's going to be -1, -6. And then this point that we had over here is going to be -1, -8. So those are the two different points if an x value of -1 is specified. All right, so, and then you can actually, if you have the time on a test, you could actually check this. You can pretend like the question is asking you for the length between this point, -3, -7, and this point, -1, -8. Use the length formula, and then if you work it through, what you're going to find is that the length you end up getting is the square root of 5. Whether you use this point or this point, whether you're finding the distance from this point to this point or from this point to that point, both lengths are going to be root 5. So you could actually check your answers with these questions as well. And so now let's do a question here where we're going to specify the y value. So the y value I'm going to use is -8. You got to be careful with what y values you choose in case maybe you're doing this on your own, because, for example, you can't choose a y value of like -10. Because notice that, remember, the shortest distance from a point to another point is the perpendicular distance. So the shortest distance would be the vertical distance. And notice that from here, from a y value negative 7 to a y value of negative 10 if we keep the x value the same as 3 units, which is actually greater than root 5. And so there's no, notice how this length would be longer than this length, and this is already over root 5. So there would be no point that we can choose that has a y value of negative 10 that would be root 5 units away from negative 3 and negative 7, right? That's why I'm putting a little bit more thought into what y value to choose. So they may actually maybe give you a question where they specify a y value where it's actually impossible to get. Okay, so you got to be careful over here. So in this case, negative 8 will work. So, because notice that the vertical distance to negative 8 is just 1 unit, right? So that's less than root 5. So there are points either here or here where that length of root 5 or 2.24 is going to be possible. Right? So in this case, what we're going to be solving for is the x values because the y value is given. And this x value might end up being positive, actually. We'll see at the end. We could just adjust the diagram. Then if it's positive, then this point should be on the right of the y-axis. But let's just keep it here for now and see what we get. So exact same thing. We're going to be using the length formula. And let's label this x1, y1. We'll let this be x2, y2. It doesn't matter which you label. You're still going to get the same value. But in this case, notice that we're going to be solving for this x value. So we're going to have root 5 equals root x2, which is negative 3. Let me actually put these in square brackets. We're going to be dealing with some negatives. So x2 is negative 3 minus x1, which is x. This is a comma, by the way. This x, that's what we're going to be solving for. And then that's going to be squared plus y2, which is negative 7 minus y1, which is negative 8. That's going to be in brackets. And that's going to be squared like that. So notice the square roots. We square this side, both square roots go away, so we end up with just 5 equals. Over here, we'd end up with negative 3 minus x squared. Let's leave it like that. And then over here, negative 7 minus negative 8 ends up being negative 7 plus 8, which ends up being positive 1. So this would end up being positive 1 squared. Okay, so we'd end up with, let me continue it here. We'd end up with 5 equals negative 3 minus x squared plus 1, like that. Bring the 1 over. 5 minus 1 would give us 4. Like that. And what's nice here is square root this, square root that. Square root of 4 is smooth. That's going to give us an integer, 2 integers, plus or minus 2. And then we got negative 3 minus x. As we showed before, this isn't always going to be smooth, right? Sometimes it's going to give you a decimal value here. Either way, same thing applies. So in this case, we have a negative x here. I'm going to bring the negative x to the left side to make it a positive x. And then this plus or minus 2 I'm going to bring over to the right side. Still going to stay plus or minus, right? Because this positive would turn into this negative, then this negative would turn into this positive. So it still stays as plus or minus 2 even when you bring it over. So notice there's 2 solutions, negative 3 plus or minus 2. So either negative 3 plus 2, that's one of the x values, or negative 3 minus 2. That's the other x value. So this would end up being -1. This here would end up being -5. So this x value would be -1. This x value here would end up being -5. So this x value was negative, so we don't have to adjust the drawing. That point would be to the left of that y-axis. Okay, and again, you could take something like this, test it out. Find the length between these 2 points, or find the length between these 2 points. You're going to see that the length would be indeed √5.